Ciao friends! In this video we're going to see how to implement a security configuration for an organization where account employees are managed by a hierarchy of managers, and we want to reduce at the minimum possible the way we define the security configuration for users that have to access to this report by using just a list of the managers that they want to see. We will see the list of the requirements where we understand that the hierarchy of the managers in a large organization, maybe with hundreds or thousands of employees, could bring to a number of steps in the definition of the configuration for the security in order to make it also efficient. Because one of the challenges when you have the security configuration is to make sure that you don't slow down the reports that you are going to create. And in a large organization with a hierarchy of managers, the risk is high that you get slow reports. So let's start with the demo. Let's start taking a look at the final result we want to obtain. In this model I have the solution already implemented, and you see that we have the classic Contoso database where we have the sales, the classic sales connected to product, connected to customer. But in this case, every customer has an account, an employee account, and each account should have a manager. And we also have a hierarchy of managers that actually manage the entire sales organization. Imagine we could have thousands of employees in this organization. So one of the issues we have is that we want to simplify the configuration definition, and we want also to make it efficient, because if we have a slow definition of the filter in the security rule, that could affect every report. So the goal we want to obtain is the following. Here I don't have the security applied, but we want to define for each user that can access this report a limitation to the managers that user can see. Being able to see a manager means being able to see the entire organization below that manager and all the employees that report to those managers. For example, if I connect by impersonating a user, for example, marco@contoso.com. Marco has access to two managers, and please take a look at the value that now is 12 million in the total sales amount in both of the reports. And you see that we have two reports. One shows the sales by brand, and one shows the sales according to the management organization, so just the list of the manager and the sales amount for all the employees and manager below each node. So once I click marcocontoso.com, you will see that these numbers change. I click OK, and the total amount is just less than 6 million now. So we have less than half of the sales. Why? Because marco@contoso.com has access to only, if I remember well, John and Heather. Now, please pay attention to Heather, because Heather has a manager, Peter, but Peter has also other managers below him, and we don't have access to those other managers, which means that also the value that is visible for Peter is actually the value of only the manager we are allowed to see for that part of the organization. Indeed, if I stop viewing by using marco@contoso.com, you see that Peter has Heather and James below. So we didn't see the value for James once we apply the security. So this is what the security is intended to be, a way to filter data no matter what in any report, regardless of the dimensions. Indeed, you have seen that also the sales by brand were affected by the effect of the security implementation. This is the final result we want to obtain. I now move to a model where I didn't implement the security yet, so we have access to the entire model at this point, but we already imported what we want to be our table to define the security. So if I go in permissions, this is a table that we imported. Let's see here. We imported from an external configuration. It could be an Excel file, a SQL Server table, and the minimum number of information we want to define is the following. For marcocontoso.com, we define only the two manager names. In this example, every manager name is unique across the entire organization. We will see later an example where we implement the same model, but with the difference that every manager name is unique only considering the entire path. When you have a large organization, you might have this problem. So if you don't have a unique ID to identify the manager, you identify the manager across the entire path to reach that node. We will see this later. Now you notice that Margot has also a third manager that should be visible, but Mikil doesn't exist. Actually, Mikil is a typo. There is a manager called Nikhil with the N instead of the M. If I go back, I should be able to see that Nikhil is indeed here with the N, but I intentionally wrote an error in the configuration because I want to see how I could manage errors in the configuration, creating a report to actually display these problems, because of course Marco will not see Nikhil, will not even see Mikil because it doesn't exist. But we may want to report this error in the configuration later to make sure that someone will fix it. So this is the starting point, but how is the existing model defined? Because we didn't see the existing model. So the existing model is the following. So the permission table is the table that we see here is isolated, is a table that doesn't have any relationship with anything at the moment. And our sales table that I can see here in this zone, in this area, is connected to the customer table. Now the customer table has a many-to-one relationship with the organization. How does it work? Let's take a look. So we have, you see two columns. We have account employee and employee here. So let's start from the customer table. The customer table has, for each customer, we can see this here, for each customer has an account employee. Of course, every account employee could manage different customers. Now, every account employee, every account, has a manager. And where do we have this information? Well, this information is included in the organization table. In the organization table, we have this structure. Oops, sorry, I typed too many keys. So the employee column is a unique column for this table. So for each employee, we can see who is the manager that manages that employee. And in case there is a hierarchy of managers, so the manager of Ada has a manager and that has another manager, we actually see these three levels of management defined here. This is the way you have to define this table. If you have a different data source that, for example, defines this table through a parent-child hierarchy, I suggest that you take a look at the parent-child pattern published on daxpatterns.com to see how we create actually the same structure we see here, where we have what we call a reged hierarchy, which means that in a few cases we have 3 levels, in a few cases we have 2 levels, in other cases we have 5 levels. So we could have a different number of levels, and this is a typical situation we have in many organizations. Now, starting from this structure, we created 2 columns, the manager ID and the depth. The manager ID is simply the concatenation of all the manager names across all the levels that are visible, separated by a pipe. Why we do this? Because this way we can easily obtain this number, the depth of the organization, which can be helpful to create measures that hide the levels that don't have meaningful data. This could be useful, but again, this is part of the pattern for the parent-child. Now, if you think for a moment, the organization table is connected to customers. So one approach could be, well, we could use a function that look for the name of the manager within this column, because at the end of the day, if we can make the assumption that every manager is unique, if I have access, for example, to Stephen, well, Stephen will give me access to this node, but not to John Russell or not to John Carmen Francesco Fiona Charles. So we actually already have a relatively easy way to define that. But what is the issue? If we define the security straight in this table organization, we will pay a big price for the performance. And we also have to write a more complex rule to find the string. But the thing is that every query should have to scan this table looking for the content inside a query. So the idea to keep the existing configuration, which is very simple, is to expand this table so that we actually obtain a direct list of all the employee names that are visible for each account assigned to a particular user. Because by doing that, we can actually have an easy way to define the security so that it automatically propagates to the table organization in a very efficient way. In order to do that, so we have to create a table that we will connect to the organization table. What does it mean? I expect to create a table here which create a list of all the employees I can actually filter, and I will create a relationship between this new table and the organization table, for example. And this should make it easier to apply the filter, because I will just filter a column that I create here with the username, so that for each username I have exactly the list of account employees I can filter. That's the idea, to remove the analysis of the organization from the evaluation of the security when the query runs, because we can create a table, maybe a calculated table, so it's automatically updated, that has this information computed only once whenever we refresh the model. So we move the complexity at refresh time, but we execute this only once, and the small price to pay a new table in the model should be relatively cheap, because we will have a very high compression, because we will duplicate many rows, many values in many rows. How can we do that? So as we said, we have to create a calculated table. So in order to create a calculated table, we I prefer to go in this visualization, because here I can actually see the content of the table in terms of name of the columns. And the table I want to create is a table that I will call permissions expanded. So permissions expanded. So let's start with a simple copy of the existing table. The existing table is permissions. So we can see the result of this table is just a copy of the existing table. The first thing I do, I just want to rename these columns, because this way I obtain names that are more meaningful in the table I want to obtain at the end. And so the rename can be obtained by using select columns. I just want to rename actually one column, but I have to copy the user column, because I want to keep the username, permissions user, and then the new column, the column that I want to use, is the assigned manager ID. So which manager has been assigned to a particular user. And in this case, I write assigned manager ID, which is the permissions manager ID. Okay, so I made a small mistake probably when I defined the goal of this table. I don't actually, I don't have to create the list of the users that I can see. I mean, I could, but this could, expand the table more than necessary. If you remember, I had a column that contained the ID of the manager by using the entire path. And I could use that information, because that information is unique for that manager name in a point in the organization, and I just have to list all the possible values of that column, because this way I reduce the number of rows that I have to transfer in this filter, and I will leverage on the existing organization table, so that I don't have to create a larger. Imagine you have 20, 30,000 employees. I actually can just create an intermediate table that has only the list of the manager, including the managers below the manager I can access, and the expansion to the list of the employees can be made by just applying the filter over organization, because organization already has that. So my goal is that for each row in the permission table, I want to create the list of the managers that are below the manager that is assigned. For this reason, I started with the assigned manager ID, because I want to create another column that I will call manager ID that has the list of the managers. How can I do that? Well, I can use the generate function. The generate function is an iterator, and for each row of select columns can execute another table expression with a current row context in in this case in the permissions table, and the rows generated by this table expression will be merged and joined, let's say, to each row of the permission, so that, for example, if the first row in the permission has 5 managers, we will get 5 rows with the same 2 columns at the beginning, user and assigned manager ID, the new column, manager ID, which is the list of the managers below that manager, including also the manager we want to filter. How can we do that? Well, at this point, we will certainly use a calculate table function, because the calculate table transforms the row context into filter context, and our goal is to get the list of the unique manager ID in the organization table. So that is our goal. But in order to do that, we have to apply a filter. And in order to apply a filter, we can use what? We can actually check. We can actually check whether the path we have in manager ID, because remember, manager ID is the column that contains the entire path. If that path includes the manager ID we have in permission. So we have this permission ID that can be used as a filter to search whether the path contains that name. We have a function, path contains, that can do exactly what we want. So path contains can check whether the manager ID includes my permission manager ID. The idea is that every ID is unique, so the presence of this manager ID in any point of the hierarchy is enough to make sure that this will work. I just have a problem now. By using the context transition, I lose the access to this value. I no longer have the row context. I would have the filter context, the context transition, and so the filter context, but this is unnecessarily complex, so it's easier if I store in a variable, assign manager ID, the value of the permissions manager ID when I have still the row context available, and then I return the result of this calculate table. At this point, I can use this variable here. And the other thing I do, I want to avoid any possible issue of circular dependency, because now we are going to create a new table, then we will create a relationship. I just want to make sure I don't have other filters involved. And actually, by doing this, I have a context transition. Maybe that this is unnecessary, but this makes it clear that I don't need any context transition out of this calculation. And let's see if this works. So I don't know why we have this error, but let's try to include this. The manager ID is not available. Oh, right, because at this point I renamed it. That's clear. I renamed this name just to avoid a confusion between the two different names. So actually, I'm using the permissions manager ID, but because of the rename, I have to use the new name. And the reason why I had to use the new name is because otherwise I would have obtained two columns with the same name, because you see that the column I'm adding is manager ID. So let's try now. This should work at this point. And this is the result we have. Let's take a look. So we have, let's sort by username so that we have all the rows for Marco and John here. And you see that Marco actually expanded all the paths that include John. We only see the path that exists in the organization table. You see that, for example, we have Charles, we have Stephen. We don't have Fiona, for example, because there are no employees that report to Fiona in the simple organization table that we have. But otherwise, we would have had the entire list, all the unique combination, unique nodes and unique paths that we have starting from John, because John was included in our definition. Then we have, if you remember, Marco had header, which is here, and because header is here, now it includes Peter, but Peter is included only for the path that has header and anything below. Now, in this case, we have a small number of rows in the organization table, but you can imagine that this list could be larger if we actually had thousands of employees. Larger, but not as large as the organization table. So actually the number of rows we obtain here is more compact, even though we repeat this list for each user. So depending on the number of users we have to define here, this list could be long. But remember, when the security filter will be applied, only one user will be filtered, and so that should be relatively fast. Now that we have this table, what should we do? Well, at this point, we have to go back in the data model view, because now I can create a relationship between, let's see if I can highlight this, between the manager ID column and the manager ID column. We actually have the same column name, but also the same content, because actually we copied that column here. And an efficient way, because the goal is that we want to filter the user. So we want to filter the user. By filtering the user, we want to filter the list of the manager IDs that this user can see. And by propagating this filter to the organization table, we will also filter the employees and then the customer that had to be filtered starting from that user. Let's do that. So I just create a relationship. And in this case, because we don't have a primary key on any of the two sides of the relationship, we have to create a many-to-many cardinality relationship. This is good, but what is not correct in the default provided by the Power BI user interface is the cross-filter direction. What we really want to do, we want only permission expanded filters organization. So this is the only filter we want, single permission expanded filters organization, because we don't want to introduce a bidirectional filter and any ambiguity in our model. There is no need for that. So we want this one, and once I do this, permission expanded filters organization, I have this kind of definition for the relationship. So the relationship is a single filter relationship. Let's see if I can highlight, where when I filter the user, I filter all the managers for that user, and this filter is propagated to the manager ID column here that will filter all the employees. So far so good, but I still have to do the last mile. I have to complete the last mile, which is I have to define the security role. So in order to do that, I go back to the report view where I go in modeling and I go in manage roles. I already created a role, a security role manager view that is empty at the moment. And the only table I have to filter is this permission expanded table. I have to go to the DAX editor, because what I want to do, I want to filter the column user that has to be equal to username. So this is the expression I have to write. Unfortunately, the editor doesn't have IntelliSense yet. I save this new rule, and now what happens? Now I can try to apply my rule. So I click on View As, and I use Manager View because I want to use this security role, and I also want to impersonate marco@contoso.com. So if I click OK, let's see if this works. And as you see, the security has been applied, only filtering the data that Marco can see. So actually, I successfully implemented the security. And as you see, now we have the security applied only on permissions expanded table. If I go in permissions expanded as a table view, I only see the rows for Marco. At the moment, I didn't filter the original permissions table. So if I go in the permissions table and I can actually see the entire content, in theory, this table is hidden, but technically the user could see the content of this table. If for any reason you don't want to make this table accessible to any user, one thing you could do is to add in the manage roles another filter for permissions where we say only false, because this way we hide the complete configuration, or we just repeat the same configuration we used in permission expanded, where we filter user equal to username. Actually, I didn't want to add this security filter because I wanted to make it clear that what matters is the permissions expanded table. So the security filter we might add to permissions doesn't have any effect on anything. So probably I prefer to use false, because this way, if the user with a direct access to the model tries to look at the permissions content, you see that even though I'm filtering by marco@contosa.com, this table is completely empty, and the permission expanded table is the only table where actually Marco can have access to some data. In theory, these tables are hidden. I should also hide a table permission expanded, to be honest, because this table should not be visible to the user. Only the organization table should be visible to the user, and this way the user only sees the data that can access. Now, if you remember, there was only one potential difference in the model, which is what happens if, let's stop viewing the security, what happens if the definition of the manager should consider that the manager name is not unique. If the manager name is not unique, the only way to uniquely identify a manager is by using the complete path. For example, if I want to identify header, I should use the path that reaches header. So technically, this manager ID Peter header is never mentioned in the organization table, but I know that the initial part of the path should be equal to Peter header. So what we can do, so we can see this already prepared in the model that I showed you at the beginning. In this model, we have the same configuration. The only difference is that the permissions table has for each manager the complete path. Peter header, Jeff Mikkel, and this is the content we have. But the definition we used in the calculated table that generated the permission has only a difference in this line, where instead of using path contains, we compare the initial part of the string. So we use this left, where we compare the length of the assigned manager ID path that we have in the permissions table should be equal to the initial part of the string that we have in the organization table. The result is the same, but this way we have an alternative way in case the manager name is not unique. Last thing, if you remember, we have a typo. So now we can see this typo in this case where Mickey is with the M instead of the N. And because of that, you see that the manager ID column in the table that has been expanded by using generate is empty. Why this is empty? Because what is happening is that the row that contains Mikkel generates an empty row by trying to filter by using Mikkel, in this case with the left, but the same will be true also with contains. So how can we display this situation to the user? If we just want to create a report where we show the list of the errors in the configuration, we can create a simple table where we display the user and the assigned manager ID from the permissions expanded table by applying this filter, where we say that the column manager ID is blank. By doing this, we automatically have a filter of all the values that are not found in the organization table, probably because of some mistake in the configuration table. As we have seen, it's possible to create a very simple configuration table that enables the access to a complex hierarchy with managers and employees account. And the same approach could be used in general when you want to implement the security over a hierarchy of nodes, and the rules have to respect the structure of the hierarchy. Sometimes this could be seen as a complex thing, but by splitting the problem in smaller problems and creating a table that simplify the business rule to apply at query time in the security role, we obtain good performance. And usual, enjoy DAX.